In this video, I want to review how to find the equation of a line and slope-intercept form with given a graph, given tables, and given 2 points. Alright, so in the first two problems here, we're going to look at the graph. So to find from a slope-intercept form is y equals mx plus b. So I need to find the parameters, which are m and b. Let's review what those are. So the m value for m represents the slope of the line. And the value for b represents the value of the y-intercept. So on these graphs, the first thing we do is we find the y-intercept. And so in graph 1, the y-intercept is at the point 0, 2. So it might be helpful to label that. And so that means the b value is going to be 2 in my equation. So in my equation, I know mx and b is 2. So I'm going to put a plus 2 right there in my equation. Now to find the slope, we're going to make a slope triangle. So I'm going to find another nice point, a lattice point. So the points have to go through a nice intersection point of the grid. It can't just go through any random point, so you have to be very careful. So in this case, one point would be this one right here. Okay, so I like to label that point. Okay, plot it, and then we're going to connect them with a triangle. So I'm going to draw a right triangle from here down. And so slope is, remember, slope is the change in y over the change in x. So to find that delta y, we go left to right on the triangle. So I start at the left point. See how many units it takes to go from here to the right angle. So it's going to be 1, 2, 3. That's a positive movement of 3. And then from there I go up 1. And so this right here is my delta y value, and this right here is my delta x value. And so my slope will be delta y1 over delta x3, 1/3. And since 1 and 3 are not divisible by any other number than 1, I'm going to take the m in my equation, replace it with 1/3, and that is the answer to my line. So if you haven't done so, pause this video, try to find the equation for graph number 2. Okay, so I'm going to find the b value. So again, my equation is mx plus b. My y-intercept's here. So that seems to be the point 0, -1. So the b value is -1. So my equation, I replace the plus b with a -1. Now I'm going to find another lattice point, another nice point. So it looks like one of them is right out here at this point there. So I'm going to connect them together with a slope triangle. Here's my right angle. And so I start left to right, so I start at the y-intercept, I have to go down 1, 2, 3. And from the right angle, I have to go over 1, 2, 3, 4, 5. So again, this right here is my delta y value, and this right here is my delta x. So my slope is going to be delta y -3 over delta x positive 5, which is just -3/5. And again, 3 and 5 are not divisible by another number other than 1, so I can't do anything about it. So my slope is -3/5, and so that is my equation to that line. Okay, the next one we're going to do is look at some tables. So again, how do you find the equation of a line given tables? So first thing we want to know is that, I'll put some more notes over here. So the b value is the y-intercept again, right? Well, the y-intercept is always the point 0 in b. And again, my slope is delta y over delta x. So how do you find those values? So first thing I do is I find the slope. I find my delta y over delta x. So I'm going to find the change in my table. So notice how in my x values, all of them are going down up by 1, plus 1 over and over again. So that is my delta x. And since x is going up by the same amount of time, whatever my y values are going up or down by is going to be my delta y, which that looks like it is positive 15. That's delta y. And so my slope is going to be delta y 15 over delta x1, which is 15. So in my equation, m is 15. So now I got to find b. So b is where the y value in x is 0. Well, in my table, it's nice that this row here has an x of 0. So the y next to it is my b value. So in this case, b is 13. So we're going to erase the b in my equation with a positive 13. And there is the answer to that line. Okay, so if you haven't done so already, try problem 4, pause the video if you haven't done it yet. Okay, so let's find my delta x first. So again, you can see the tables are counting up by 2's. That's my delta x there. And then as a result, whatever the change in y is the same. That looks like it's going down by 14. And so my slope is delta y over delta x, which is negative 7. So my equation, we're going to put a negative 7 in the x place. Now to find b, we see in my graph, my table, there is a row when x is 0. So the y value next to it is the b value I want, which would be 35. So I replace the b with positive 35, and there's the equation to my line. Now number 5 is a little different, so let's go through it. So we're going to find the slope. So again, we're counting up by 1s. It looks like we're going up actually by 12 each time. And so my slope is going to be 12 over 1, which is 12. So again, my equation looks like this. But unlike the other tables, this doesn't have a 0. So we've actually talked about a technique of finding b if I know a slope at another point. A table turns out to be a bunch of different points. So I'm going to choose one, probably the first one. And we're going to plug in x is 1, y is negative 16 into what I have down here to find b. So I have negative 16 is going to equal 12 times 1 plus b. Well, 12 times 1 is 12. Subtract the 12 over, I get negative 28. So my b value should be negative 28. So I'm going to erase this, put negative 28 in its spot. And there is the equation to that line that table represents. So you're going to be asked a lot in upcoming assessments and homework throughout the course of this year is you need to be able to find the equation of a line if you're told a table represents a line. So there's a few examples how to do when x goes up by 1s with the x value 0, x goes up by 2s with an x value 0, when x goes up by any amount when you don't know 0. Okay. Okay, the last type of problem is intercept form with 2 points. So again, the first problem, we notice that one of the points has a 0 as x. So we know that that means the y value is the b value. So that's 1. So my equation, I have this as my answer so far. And the other point can be xy. So when you're given the b value and a point, we can just plug into what I have down here to find m. So we're going to go 2 for y equals m times x would be negative 5m plus 1. So let's solve this. So we'll subtract 1 from 2 and divide by negative 5. And so this is my slope. And so I replace that with m in my equation. And so the slope of my line would be negative 1/5 x plus 1. Now in problem 11, we're given 2 points. So we're going to use the slope formula to find that, which is it's not that. It is y1 minus y2 over x1 minus x2. So the sub 1 values come from the first point listed. The sub 2 values come from the second point. So we'll plug those in. So negative 2 minus 5 over negative 1 minus negative 5. And we'll see what we get. Negative 2 minus 5 is negative 7. Negative 1 minus negative 5, well, minus and negative is positive. So negative 1 plus 5 is 4. So my slope is negative 7 over 4. So again, if I look at my equation, this is what I have. And so I'm going to choose one of the points. So I often will choose the first point. So let's use the first point. We're going to plug those values in for m and x and y, and what I have below. We'll solve what I got. So we got negative 2 is going to equal negative 7/4 times 1, negative 1 plus b. So we got negatives canceled. So we got negative 2 equals 7/4 plus b. Now to get rid of fractions in equations, let's multiply the entire equation by 4. Negative 2 times 4 is negative 8. 7/4 times 4. So multiplying and dividing by 4 cancels, gives me 7. And I got b times 4 is 4b. So we're going to subtract the 7 away, which gives me negative 15. And divide by 4, which gives me negative 15 over 4. So replace the b with negative 15 over 4. And that should be the answer to my line. Now, reminders are often our slopes are in fraction form. So if we're going to write our slope in fraction form, our b value should be written in fraction form as an improper fraction. Now you could write this answer in decimal form. So 7/4 and 15/4 are nice decimals, but we often try to leave our answers in fraction form, and especially in an equation of a line, as improper fractions. So those are a few reviews on these checkpoints for checkpoint 5B in the course. So I'd use this to help you complete reviews and study for upcoming exams and do problems similar to these on the homework. All right, thanks for your time.